Welcome back to Nick Does Maths. We have an absolute belter of a question here today. This is from a step paper from back in the day. We have a second order differential equation here with all kinds of gubbins going on. We've got p's and q's. We've got some random function on the right. We're told it can be written in the form x to the a, x to the b, x to the c. All right, fair plays, I'll believe you. We need to use that to solve all of this, but with f of x is 0, and then we're going to solve it with f of x is x to the n, but there's a slight twist in there. Let's see what we can do. So I think the first thing to do is to actually try and figure out what a, b, and c need to be. So let's start with the inner function. What's x to the c y dashed? Well, that will be c x to the c minus 1y plus x to the c y dashed. So let's times that in there by an x to the b. We get c to the x b plus c minus 1y plus x to the b plus c y dashed. And we need to differentiate that. So I end up with c b plus c minus 1, x to the b plus c minus 2, y, differentiate that term, keep that one, plus c x to the something, boop, c x to the b plus c minus 1 y dashed. Next, differentiate that. B plus c x to the b plus c minus 1 y dashed plus x to the b plus c, differentiate that. Now, so this is, and then we need to times that by x to the a. So we end up with c times b plus c minus 1, x to the a plus b plus c minus 2, lots of y, plus b plus 2c, adding these together, x to the a plus b plus c minus 1 y dashed, and then x to the a plus b plus c y double dashed. Now, let's compare. So if we look at the y double dash terms, it's telling me that a plus b plus c has to equal to 2. Awesome. And in fact, if you look at the y dash term, it tells me that a plus b plus c minus 1 has to equal to 1, which is the same thing as that. And in the same way, if we look at the y term, it has no power of x, which tells me that a plus b plus c minus 2 has to equal to 0, i.e. a plus b plus c equals 2. So this condition here will deal with all of my x terms. Now I just need to look at the coefficients. There is none. OK, fine, be that way. Coefficient of x dashed is telling me that b plus 2c is 1 minus 2p. All right. And if we look at the coefficient of this one, that's c, b plus c minus 1 has to equal to p squared minus q squared. Now what I think I'm going to do is I'm going to sub that into there. So that is c lots of 1 minus 2p minus c minus 1 is p squared minus q squared. So I get a minus c squared, let's just change all the signs, minus, so I get a plus 2pc, and that is equal to q squared minus p squared. I've just swapped the sides over, but that's quite nice, because that tells me that c plus 2p all squared is q squared. So that tells me that c, c plus p by itself, okay, c plus p. So c is equal to minus p plus or minus q. Okay. A couple of these could be quite useful, actually. I'm just going to jot a few of these down as well. b plus 2c is 1 minus 2p, and we know that a plus b plus c is 2. You never know. Right, so that's that bit. Let's just solve this chonkadonk here. So b plus 2c, so that's b minus 2p plus or minus 2q is 1 minus 2p. That's quite nice. The 2p's cancel out. So that tells me that b is 1 minus plus 2q. I'm going to keep the minus pluses because I feel like they're going to cancel out somewhere down the line. And then if we put all of that into a plus b plus c equals 2, we get a plus 1 minus plus 2q plus or minus q minus p is equal to 2. That tells me that a is 1 plus p, that becomes a minus plus q, plus or minus q. Yes. All right. Cool. So long as we have these conditions in terms for A, B, and C in terms of P and Q, we should be golden. We should be golden. Okay. Now let's try and solve this using this idea. Buckle up, buckaroos. This is just a lot of algebra. Essentially, as step questions go, it's not too bad. It's just a lot of algebra. So essentially, we want to solve x to the a times x to the b, x to the cy, dashed equals 0. Because we've got a 0 now on that side. Well, the x to the a doesn't matter. So it tells me that x to the b times x to the cy dashed is some constant. Okay. So x to the cy dashed is ax to the minus b. And we're going to integrate that again. It's minus b plus 1 over minus b plus 1. Now the important thing is that's just a constant. Whatever constant a is over b plus 1, that's just a constant, but there we go. So what do we get? We get y is, now the very important thing here is when I integrate from there to there, I've made the assumption that b is not equal to 1. Because this only works if you're not integrating x to the minus 1. We're going to have to little look-see at what happens if b is 1. So we're going to get two different possibilities here. I'm just going to call this another constant, or call it a star, whatever you want to call it. Minus c minus b plus 1 plus b x to the minus c. Now, what is this? Is any of this helpful to me? Not desperately. So what's b plus c minus 1? So if I add these, right, I'll do b plus c minus 1 and then minus it. I get minus p minus plus q. So I get p plus or minus q. All right. And then minus c is p minus plus q. So, and here's where we kept the minus pluses all the way through. The point is I'll get some term x to the p plus q and some term x to the p minus q, right? If I put plus there, I've got minus there. If I go minus there, I've got plus there. So the idea is, in fact, is that that is my solution. However, what if b is actually equal to 1? Well, when I go from there to there, what I actually end up with is I get x to the cy is some constant times ln x, because I would get x to the minus 1, right? Plus some constant. So y is a ln x plus b x to the minus c. And again, minus c is p minus plus q. Ooh. But let's have a little thing, because we've said b is 1, right? So we've said b is 1, so that tells me that q is 0, basically. If I want b to be 1, that means q is 0. So in fact, that doesn't exist. Right, is that correct? Yeah, that looks about right. Cool. So we've got general solution for that thing there. What A and B are will depend massively on my initial conditions. Oof. One more to go. All right, let's go. Let's do it. I don't have space for everything on the board, so all of this lovely maths we just did is going. Awesome. 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 Right. Now then. Let's just go back to here, because we're going to get that is equal to x to the n. However, we do have some simplifications here, because if you look at this case here, we're going to take q as 0. So if q is 0, we actually get c is minus p, we get b is 1, which is very, very useful, and we get a is 1 plus p. All right, so let's see what we can do. So first things first, we get that x to the b, x to the c, y dashed is x to the n minus a. So let's integrate that. Let's integrate that. Right, so where were we? Just stuff everywhere. This is absolutely mad. Right, we need to go for this. Now, yeah. Q is 0, right? Q is 0. So we get C is minus P, we get B is 1, and we get A is 1 plus P. So in fact, how about we put those straight in? So that is x to the 1 plus P. X to the 1 and x to the minus p. And let's see what happens here. So x times x to the minus py dashed is x to the n minus p minus 1. Now again, we need to be very, very careful if this thing is minus 1 or not. So let's just start with n is not equal to p. If n is not equal to p, this whole thing is not minus 1, so I can just integrate it. So I get x to the minus py dashed is x to the n minus p over n minus p, so that's nice, plus some constant. Divide through by the x. That's x n minus p minus 1 over n minus p plus ax to the minus 1. Now we're already fine. We don't have to worry about that because we're back in the same case there. So we can just play the same game again. So we get x to the minus p y is equal to x, integrate that guy again, x to the n minus p over n minus p squared plus a ln x plus b times everything through by x to the p. So we get x to the n over n minus p squared plus a x to the p ln x. Tell you what, let's keep the same sort of notation as we had before. A ln x plus b times by x to the p. Now what if n is equal to p? I mean, it doesn't feel fun if n is equal to p. I'm going to need the board, so jot this down somewhere which you can forget about it. And finally, we've got the case where n is equal to p. So we'll get x times x to the minus py dashed is equal to ln x plus some constant. And now the greatest fun thing in the history of the great fun things. I now have to integrate x to the minus 1 ln x. Awesome. Awesome. Do you know what? I'm going to differentiate one. I'm going to integrate the other one. I'm going to differentiate the ln x. I'm going to integrate the x to the minus 1. That doesn't feel good either. Oh, actually. Oh, let's do this properly. Let's do this properly. Let's see what this does, actually. The integral of x to the minus 1 ln x dx is differentiate, so keep and integrate. Differentiate that one, integrate that one. So it'll be ln x all squared. That's my u, that's my v dashed. Minus the integral of differentiate and integrate, which is just gets me back to x to the minus 1 ln x dx. Huh. Okay. Yeah, of course it does. Of course it does. Muppet. Of course that works that way. Derivative and function. Let's go. X to the minus pi, minus py is 1/2 ln x all squared plus a ln x plus some constant b. And then we times everything by x to the p. Need a break after that. Sit down, cup of tea. Step question, just lots of algebra, lots of algebra. Only took us about 32 minutes. It's all sorted. I'm Nick. Don't forget to click like and subscribe. Tune in next time for another 4 days of me doing algebra on a whiteboard. I'll see you next time.